one is we are going into digital modulation. So we have studied about the basic thing is QPSK, BPSK, right? So why we go for digital modulation is digital modulation is more secure. So your signal is very much secure when you transmit the signal using digital modulation technique, or you call it as a pulse modulation technique. So sending data in digital modulation is very safe because whenever you have a 0, I'm going to not send anything. Whenever I'm going to have a 1, I'll be sending a sine wave. That is going to be the basis for digital modulation. Whatever I have told you is ASK. And whenever you are going to the advanced modulation, you have ASK, FSK, and PSK. So ASK is amplitude shift keying. Amplitude shift keying means whenever you have encounter 1, you will be sending a sine wave. Whenever you encounter 0, you will not send anything. That is ASK. FSK means use 2 frequencies. Whenever I have 0, I send a sine wave of 1 frequency. Whenever I have 1, I'll send a sine wave of another frequency. And PSK, whenever I have 0, I'll be sending sine wave. Whenever I have 1, I'll be sending minus of sine wave. So the phase angle will be changing. That is what I'm going to show a demonstration here. So see here, whenever you are sending more than 1 bit, you will be calling it as symbols. The group of bits is going to be called as symbols. So I'm defining number of symbols here. Initially, I'm going to do for BPSK. So I'm going to take it as 2 in BPSK. I'm going to group 2 bits. In QPSK, I'll be grouping 4 bits. Okay. So see here, I'm grouping 2 bits. We'll run the program for VPSK first. Once the VPSK is done, we'll see what the difference for QPSK. So I'm taking M value as 2 and I'm generating random signal for in phase, only in phase. And if it is QPSK, I'll be generating in phase and quadrature phase. The in phase is real, quadrature phase you see I'm adding J. Okay, so in phase and quadrature phase understanding you should have. So I cannot take that in detail now because you should know the basics of in phase and quadrature phase signal. So in phase is representing cos. Cos is a real number. And quadrature phase is representing sine. Sine is going to be the imaginary term. So that is what is added here. If M is 2 means I consider only the in phase because I'm grouping only 2 symbols. When I'm going to go for grouping of 4 symbols, I need to have both real term and imaginary term. And I'm dividing by square root of 2 for normalizing my symbols. And for analog channel, you call the parameter will be SNR, signal to noise ratio. For digital channel, you'll be calling it as EB by N0. EB is the energy per bit, by N0 is going to be your noise. So you're taking the EB by N0 in dB. I am assuming a 6 dB channel, 6 dB EB by N0. So if the number means I'm going to convert 10 power that value by 10. Okay, I'm creating a channel variable and I am creating the Gaussian random noise and I'm adding signal plus noise. So A is the received signal and W is the noise. W is the noise and the variance of the noise is given here. I told you that Gaussian random noise. Now I am plotting everything and I am seeing. This is a simple code for digital modulation. Okay, I'll run this code. We'll see whether we are getting the output. Yes. This is the output scatter plot. See, without noise, I'll noise values here, right? So here I'll make noise equal to 0. If the noise is 0, we'll see what is the actual signal transmitted. Then you will have an idea. Beautiful, right? BPSK, you send 1 and minus 1. 1 is going to represent binary bit 1. 0 is going to be represented by minus 1. I told you BPSK, I send 1 sine wave of for 1, I send sine wave. For 0, I send minus sine wave. That minus sine wave will have minus 1. So this is the receiver. See, the receiver. This will be received by the receiver when there is no noise. See how beautiful.